Hi, everybody. Paul Goosens here. So before we jump into the demonstration, which Barani is going to give, I'm just going to give a sort of kind of high-level introduction to MapleMBSE and why we think it's of great value to any organization that's either considering or has established systems engineering processes and are looking around for tools to be able to connect various different functions, different engineering activities into the systems model. So I'm just going to start by we being sort of involved in systems engineering and certainly in the development of systems designs for around about 15-20 years now, and being certainly very aware of the activities around the implementation of model-based systems engineering processes. We started to see a bit of a pattern within some of our customers, and certainly the kind of challenges that the different sort of stakeholders are facing in trying to get a successful systems engineering process off the ground. Certainly at the sort of management level, the engineering director or the program director who was charged with overseeing the success of the overall project. There's some genuine concerns about the fact that the processes as they stand are not living up to expectations. They start to begin to wonder if the results are ever going to justify the investment into developing those processes. Alongside that, we have the systems engineer who's trying to put the process together and trying to get all the various stakeholders in the project to engage in the process and provide the necessary information that he or she needs to get into the systems model, into the source of truth that's going to be used throughout the project. And very often it's a bit of a struggle to get that level of information. Typically, it's because it's all being done at a fairly ad hoc level, and sometimes it's just you're dealing with the natural inertia that can emerge when you've got various different functions that need to feed into the process, and that can you can end up with siloing of activities and of course siloing of information as well. And then we hear from the actual subject matter experts or other stakeholders who are sort of looking at this process and thinking, well, how do we engage? I mean, if you're asking us to use a specific tool to or a specific set of concepts in order to bring the results of our work into the systems model, that's going to be a tough call. So these are the kind of challenges that we see, and with MapleMBSE, we believe, and it's certainly been borne out with some of our projects, that we can actually connect all these various processes together into the systems engineering process. We can accelerate the introduction of MBSE, in your digital enterprise, providing consistent integration of engineering content into the systems model, and reduce some of that organizational resistance to new processes. And not only do we facilitate the interaction between the systems engineer and other stakeholders, but we can actually use our tool to enable effective cross-disciplinary collaboration across the organization. And fundamentally, what this leads to is reduced risk to the project. We've certainly been borne out that the use of our tools can be used to reduce errors and the disruption that can cause, and of course the costs and so forth. So it's certainly in terms of the value to the organization, the case for investing in MapleMBSE is certainly a very good one. So just to give you a sense of what MapleMBSE is, it's essentially a spreadsheet front end, and we use Excel as the front end, that has a direct bidirectional interface into the systems model. So any views that are created that are built for specific tasks, they can be created from the SysML and displayed in in a tabular form. And this also includes all the interdependencies that you may have between various elements. And then any changes that are made in the spreadsheet can then be submitted back into the systems model to update the information and keep everything consistent and in the level of the details required by the systems engineer, but also in the structure and in the way that the stakeholders intend it to be used in the systems model. Because you're using a spreadsheet front end, we have a pretty powerful tool or capability for customizing and creating those task-specific views, which Bharani will probably touch on in his demonstration. And of course, this is a very familiar interface. And when anybody is using this tool, they don't have to worry about things like what is SysML. They don't need to worry about any of the back-end structures. All of that is handled at this layer. And currently, we integrate with 3 of the main systems engineering platforms: Rhapsody, Magic Draw, and Teamwork Cloud, and recently we launched Capella. So that's what MapleMBSE is about. But very often we get asked about, well, what kind of use cases should we be thinking about for MapleMBSE? And really, there are many. I mean, these are just some example use cases and applications that we've had some direct experience of. But fundamentally, what it comes down to, if you've got tasks that require large amounts of information to be integrated with the systems model, such as equipment lists, it's a very useful, very powerful, and very easy tool to get that information into the systems model. Any kind of analyses that you're performing, safety analysis, FMEA, roll-ups, they can be very useful for doing that. Even just to be able to do some analysis of the systems model itself, impact analysis, what kind of effect does different changes to say requirements have on the overall system, design structure analysis and traceability. And then finally, any tasks that require specialist knowledge. And this really goes back to that my comment about bringing in the SMEs and getting the information that they have in the work that they're doing and getting that into an appropriate form to get into the systems model. All of this can be done very, very quickly. And the example we're going to be showing you today is functional decomposition. So with that introduction, I'd like to pass over to Bharani, and he'll give you step through this particular use case.
Okay, so for the functional decomposition, functional decomposition is just a way for us to identify what we expect from the system or what we expect the system to do for us. And once you identify the top level functions, you decompose these functions into sub-functions. And we do this up to a certain level of detail is obtained. So for example, let's consider functions of a fitness tracker. So for a fitness tracker, you wanted to track your daily activities. So this is going to be a top level function. And you can break this top level function into, say you want to track the heart rate, you want to track the sleep cycle. You also want the fitness tracker to display notifications and to calculate your calories and so on. So this is basically what the functional decomposition is going to be like, right? So you're going to identify either the functions, like the top level function or the lower level functions from the requirements, or in case if you have a very defined requirements like the functional requirements, you're going to get these information from the functional requirement. So once you identify these functions, you break it down to a level of detail. we can kind of tell that we need to break it down up to a level of basic function. So what do I mean by basic function is these are functions that are complete, and these are functions that could be defined by a requirement. So instead of just having a requirement, say that like, which is very high level, saying that you need to track your daily activity. So there will be requirements that will also say, I want to display notification from a messaging app. So the basic function would be to display notification from a message or from social media, like anything. So these are going to be my basic functions. And once you identify all these functions, you define the interface for the functions, like what is the input for the function, what should be the output of the function, how all these functions are going to interact with each other. And once you identify this, you allocate or you identify the components which will be carrying out or which is going to perform these functions. And then finally, you verify with your system requirements, you make sure that you have your functions meets all the requirements that's being defined for the system, and so on. So basically, these are what comprises the functional decomposition. And why this is important is, first you need to identify what your system must perform. And then you need to make sure that whatever functions you have identified meets the requirements that are being defined. Then this will also give you the options to find alternative functional architectures to perform like trait studies. For example, say for the fitness tracker, I want some input from the user. So this input either could be through a touch screen display or through a button, which is going to be an input for the fitness tracker. So when you're defining the functions, the function that you will be defining when you need the input to be through, say, a touch screen is going to be different from what should be carried out when you are using a button as an input. So you'll have kind of different alternatives or different functional architectures, which will evolve into different physical architecture that you will do trade-off studies. It will help you to find what are the functions that overlap and so on. So that's why functional decomposition is an important step in defining your system model. And to define these functional decomposition, there are various methods, right? So I have just listed out few of the methods that are common, but there are various methods. You might be following something that's completely different from the ones that I'm showing here. So for example, say the IDEFO, which is the ICAM definition for functional modeling, or in which you define a function, the inputs and outputs are defined on the left and right. You define with the controls, like based on some constraints or conditions when this function has to be evaluated and so on. Or we can use the classic functional flow block diagram, in which again you're going to display all the functions as like rectangle blocks, what are the interaction between the functions and so on. And when you're kind of using SysML, it's more defined using activities and action. So if you're using it through SysML to define your system model, you could use operations to define a function. Then we add more information to the operation using the activities or actions, or you can also kind of do some custom elements for some functional block, which is going to have certain specifications and so on. So with MapleMBSE, whatever your process is to perform this functional decomposition, MapleMBSE can capture this knowledge. So it could be the ones that we saw on the previous slide, or it could be something completely different, different method or a process that you are using in your own organization. So whatever it is, MapleMBSE will be able to capture this knowledge from stakeholders who are not familiar with modeling tool. So there are, as you remember from Paul's slide, the system engineers, they are going to create all this model with the modeling tool, with the complex modeling language and so on. But there are the system experts who are not familiar with the modeling tool. So for them, like functional decomposition, it's very basic. What they need to do is they need to identify what are the functions. So MapleMBSE can capture that. So if you want to break down the functions, link these functions to requirements or to the components, MapleMBSE can also capture this. So imagine for today's webinar, our scope is limited. So consider a functional decomposition where you have requirements that's defined for a system. So based on these requirements, we are going to identify certain functions. Once we identified like a top-level function, we are going to break down these top-level function into sub-functions. And once we break down these sub-functions, I want to make sure that whatever functions that we have identified, I need to link it to certain requirements. So there is a traceability that is being maintained from the new element that's being added and the requirement that's already defined for the system that's of our interest. And then these functions that we identified, we could create flows between these functions like control flows or object flow. Again, all this is within the scope of SysML. Once we define this, we can allocate these functions to components and so on. So this is not like a serial process. Like it's not just you identify the top level, you trace it to requirements of function. So this is more of an iteration. So once you again get a detail, we verify it. We miss something, we go back, we add new functions, we refine it further, and so on. So this is again an iterative process that's done up to a level of detail that we are able to obtain. And for the scope of today's demo, what I'm going to do is with MapleMBSE, we are going to show certain requirements for the fitness tracker. So based on these requirements, we will identify the functions. Once we identify the function, let's link these functions to requirements. We'll break down this function and then we'll also allocate these to certain component. So this is kind of the role a system expert would play. The system engineer, as a system engineer, he would have already created the template that MapleMBSE is going to display information to the user. And once this information is added by the system expert, we will go to a Cameo model. We will see how these information added by the system expert is reflected as SysML elements itself. So before I start making changes with MapleMBSE, so I have already defined the system, the structural aspect of it and the requirement of the system in the Cameo model. So here you can see I have like a top level requirement, which has sub requirements and so on. So for example, the requirement is going to have some specification based on the system that we want to define and so on. So in terms of behavior, I included only one activity to the system, which is just to track daily activity. So the expectation is for the system experts to work with MapleMBSE, add some information to it and save it back to the model. And also to make things simple, I have already created the physical aspect of the system. So usually it's done in a way where you identify the functions, and based on these functions, we identify the component which is going to be responsible. But to make it simple for scope of this webinar, I already have the physical architecture. So we are going to create certain functions and allocate these functions to the physical components here. So here, I have the same model. I have opened it in MapleMBSE. So MapleMBSE is using an Excel user interface. And you can see in the top of the screen that the model that we are connected to, that's open in MapleMBSE. So this worksheet is just an introduction worksheet for a system expert that says, for example, the functional decomposition. This is a worksheet that is used to create new functions and sub-function hierarchy. So the kind of, it's just a description of what each worksheet is and what the user can do. So let's go to the first worksheet. So the first worksheet is to refine the requirements and identify the function. So you can see that there is only one function that's in the model, which is the track daily activity, as we saw in Cameo. But there are a list of requirements based on which we now want to identify the functions, right? So for a user to add a new function, they just need to add a name for the function, and we are going to create the function. Let's add few functions based on the requirements. So for example, say we want to display the calorie count. So I'm going to create a function to calculate calorie. We want to track sleep cycle. So sleep cycle and so on. So once I create these functions, if you remember from the slide, I want these functions to be linked to the requirements that's in the model, right? So to calculate calories, it's going to be related to this calorie count. So I'm going to add a check, which is going to create that relation between the function we added and the requirement that's in the model. So once this is added, once I save this model, you'll see how these relations are being reflected. But for now, I'm just going to add check based on the function and the requirement. So for the sleep cycle, I'm going to again add a check here. Let's create a few more functions. So this is for sleep cycle. For steps, let's create something a function to track steps. And I want to relate this function to the requirement to track step. Then let's use notifications. I want to say display notification function. And so on. So again, I'm going to link this to notification requirement. So like this. So for now, I've just added 4 new functions, created certain link with the requirement. So at this point, let me save to the model. We will see how these requirements are being reflected. This check between the function and the requirement, how this is being reflected in the model. So I'm just going to double click on the save button, which is going to give me a dialog box to add comment and commit. I'm going to say add a new function. So in Cameo, I'm going to update my model. So you can see that we have only one function here, and I'm going to update my model here. So once the update is done, we'll be able to see the different functions appear. So here we are able to see the functions that we just added. I'm just going to drag the functions into the diagram. So here, these are the functions. We also added certain relation with refine. I'm just going to drag and drop it here. So we are able to see that, so display notification of function was added, and it's being refined from the requirement called message notification and so on. So this is what MapleMBSE can do. You can see here that nowhere within the Excel worksheet we mentioned that the activity should go into an activities package or where the requirements are going to come from. I'm just displaying a view in which the user can identify the functions and link it to the requirements based on which the function was identified. So let's continue to the other worksheet. So now I've identified certain functions now. Now what I want to do is I want to break down these functions, like these high-level functions, into more refined function. So for that, I'm going to use the functional decomposition worksheet. Here you can see that I'm just listing the functions on the top level. So let's use that. I want to say the top level function is track daily activity, rest of 4 or like sub functions for this. So I'm just going to copy this information, add it here, and just copy daily activity. So what this would add is that track daily activity as a sub function to calculate calories. Track daily activity also as a sleep cycle, track steps, and so on. So I can again use this view now to break it down further. For example, let's use the display notifications and break it down into what are the other functions that has to be done in order for this top level function to be performed. So I'm going to say display notification. And so to display notification, I want to connect to a smartphone, or because that's the only way I will be able to get the information that there is a new notification through phone. So this is a new function, and the new line appeared automatically because we already mentioned that the display notification is a sub-function for the track daily activity. So similarly, again, for display notification, I want to say sync data. So this will help me to synchronize data from the activity tracker to the smartphone and the vice versa. So again, you will see another level of hierarchy. So with again display notification, say I'm using Bluetooth or to connect to it. So so another function that's been added. And so let's also define another hierarchy so that we will have an hierarchical view when we view this information in Cameo. So let's use the activity to track heart rate. So that's another activity that's also based on a requirement. So either I could add this new function in this view, or I could directly add in this view, then go back to the other view and make a testability. So I'm going to say track heart rate. So now a new function has been created, and I can just break down this new function to other sub-functions, like say to track the heart rate, I need to first create information, and again say to track heart rate, I want to send a light pulse. See this specific function, so I want to use light pulse to track the heart rate. So it's and then based on the light pulse, what is being written back, we will be able to calculate the heart rate and so on. And now I've just added a function here. I could go back again to this previous worksheet. You can see that track heart rate will automatically appear here. I can say that this is now linked to the requirement to track heart rate monitor. So again, maybe all these sub-functions are also related to this top level requirement and so on. So now I have added certain hierarchy to the functions. Now, again, before I move on to the other worksheet, I'm going to save this. We will see how these information are again reflected in the SysML model, and then we will come back and move on to the other worksheet. So again, I'm going to save my changes here. Hierarchy. So here I'm again going to update my model. Okay, so let's bring the newly added information back here. I'm going to just clear this and bring all the information again. So now you can see that the way the functions are being broken down, like the track daily activity. So this is a function which has display notification, track steps, sleep cycle, so on. And display notification, it has sub-functions like connect to smartphone, turn Bluetooth on, and sync data. We can also notice that for the heart rate, this is being kind of separated because from MapleMBSE, I did not mention that track heart rate should be a part of the track daily activity function, which is the top level function. So once a system engineer reviews and he finds that there is something that has to be done, I'm going to create this hierarchy here, and I'm going to save my changes back to the model. So added new hierarchy, and now in MapleMBSE, the user who is going to interact through MapleMBSE, they'll get notified in the system tray. So you'll not be able to see it in the screen, but you'll get a notification. And once you get a notification, you can use the add-ins menu. So this is some functionalities that we have included to get the latest information. So again, I'm going to update my model. And once the update is done, you'll be able to see that the activity will also have the get heart rate assigned to it. So the functionality is both ways. So if a user adds some information here, they'll be able to see that in MapleMBSE too. So actually, there's something that I missed here with the model that was added in Cameo. So if you can notice that from MapleMBSE, what we are doing is we are creating just a composition, but since it's a direct composition, this was not updated. So I'm just going to change this to a direct composition. And then we'll be able to see the relation between track daily activity and the heart rate. And hierarchy. And now I'm going to update. So this also kind of restricts the user from adding some random information to the model, because you can see that from this specific view, whatever the user creates, they can create only a composition hierarchy between the activities. So it is impossible for the user to make a mistake like creating a direct composition or using an association or an aggregation, etc. So now you can see that the heart rate is kind of assigned as a subfunction to the track daily activity. So as a system engineer, you can also control what information goes into the model, how you want this information to go into the model, and where in your model you want the information to be added. So let's now move on to the final worksheet, which is the allocation matrix. So here, what this matrix is going to display is it is going to display all the components. So the user can add new components here, add new functions again in this view. So if you add a function, it's again going to be reflected in all other worksheets too. So here it just displays a list of all the unique functions. And I can allocate each of the function to a component that is going to perform that function. For example, say connect to smartphone. This is going to be done by the Bluetooth IC. So again, adding a check here is going to create that allocation relation. Display notification, this is going to be done through the screen. So we are going to allocate the display notification to screen. Synchronize data, maybe with the tracker subsystem is going to sync the data. And to track the sleep cycle, maybe it's not just one component that is going to perform this function. I can say maybe the accelerometer is going to be involved. Then for the light sensor, this is the one that's going to send the light pulse. So again, a check here is going to make sure that this function is allocated to this component here. And Bluetooth IC, in addition to connect to smartphone, it is also going to make sure that turning on the Bluetooth. So this component is going to perform these two functions. And once we kind of allocate now all the functions that we have added to the components, again, I'm going to save this to the model. We are going to see how this is being reflected as SysML elements. Okay. And I'm going to update the project here. Okay, so I'm just going to bring the relations that were located. So share. And let's also bring the refined relation. So from MapleMBSE, these are the elements and the links that we added. For example, we created the refined relation between the heart rate to the activity. So the activity heart rate monitor requirement is refined by the activity called track heart rate, the track heart rate as other sub-functions, like it has to send light pulse, it has to get the heart rate information, and etc. And specifically, this sub-function sync data is related, or let's go with the send light pulse. It's this one is allocated to the ambient light sensor. Same way the other allocated relation, for example, the function, simpler to view. Okay, the function display notification is allocated to the screen. If you remember, we added that relation here. And the connect to smartphone function is allocated to the Bluetooth IC. So this satisfy relation, they were already in the model. So that's why they are being shown as relations when I drag the information. But the refined relation and the allocate relation are the ones that we created through MapleMBSE, like the connect to smartphone and the Bluetooth IC, the refined relation between display notification and the hierarchy. So you can kind of see how easy it is for a user who doesn't know SysML or who doesn't know the MBSE process to use MapleMBSE to perform functional decomposition. So this is where MapleMBSE kind of adds value. It's very fast. You can customize it to fit to any of your process, and you can easily start off with it, add information, and display it as a SysML element. You can kind of populate a model that has no information, like the one we started with. There was no information about the activities, what are the traceability should be there, what are the sub-actions, and etc. But we were able to see how quickly we were able to identify new functions, break it down, link it with the requirements, and also allocate to different components and so on. So in terms of use cases that specifically to the functional decomposition, in addition to the ones we saw, we can create functions as like functional blocks, like if you're having your own custom functional blocks, or you are using operations to define the functions and then link it to an activity, or if you also want to link the different functions with each other, like if you want to define an input or an output parameter for a function, and so on. All this information could be captured from MapleMBSE. In a view that we kind of interacted with in a very simple view, the system expert can use this information, add their own content into your system model and save it, and all this is going to be reflected as SysML elements itself. So I'm just going to pass it back to Paul for a quick summary of what we saw today.
Okay, thanks, Bernie. It just so that some of the takeaways from what Bernie's shown here is that MapleMBSE allows many decomposition tasks to be directly connected to this systems engineering process through this familiar spreadsheet user interface. It allows many SMEs to engage with the systems engineering process without having a disconnect between the engineering content that's within the SME's realm and the systems model, without having to learn MBSE tools or even the concepts behind it. All of that is buffered within the MapleMBSE technology. And overall, this can only benefit the process. If you have consistent knowledge capture by all stakeholders, let's minimize the risk, providing richer, accurate engineering content in a consistent structure throughout the process. So, if in case you're wondering, well, how do we engage? If you'd like to start taking a step further with MapleMBSE and try and understand how you can use it within your own organization, we at MapleSoft have a very strong history in systems engineering, right through from modeling, simulation, analysis tools, through to MBSE tools and the sort of connectivity and the integration that's necessary to really start building your own digital thread or digital tapestry between the various processes. So we're not just about MapleMBSE, but we can certainly help implement your systems engineering processes with MapleMBSE as a very powerful tool to get everybody engaged in the process. So with that, I'd like to thank you for your time and attention. If you'd like to find out more, we do have a webpage for this, MapleMBSE.com. So with that, thank you, Barani. Thank you, everybody, for your time and attention, and have a great day.